Hello everyone, I'm Charis, your physics teacher in Senior 6. Remember, we are on production of sound waves. So we started by sound waves produced by open ends pipe. Second one, where we have an end which is closed, another one is open. But also you may ask yourself, why are we using Charis with a string like this? Very simple. You can read here, vibrating strings. Remember, we are familiar with strings. Like when you are on a guitar, you know that you are using strings. And those strings there are attached at both ends, at this end and this end. So now we are going to deal with how can we produce a sound wave by using vibrating string. Like if the string it is vibrating, okay? If this string is vibrating, it can produce sound waves. Very interesting. You can see that it can produce sound waves, but you are going to use a diagram to show how this one can be produce sound waves. Thank you very much. Now let us take an example. Let's take this one end and this one another end. This one has length L. Suppose that this is the length of this string, okay? This is the length of this string, okay? That's the one. Now, don't you see that here it is attached to this, and here it is attached to this medium. Now, what if you can have a sound which is produced like this, okay? Remember, before, one end was open, another one, two, they were open. Now here they are closed at both ends. To mean, here the length will be equal to the wavelength divided by 2. Now, and this, let us find the fundamental frequency. Remember, don't be confused. When I'm saying fundamental frequency, the fundamental frequency or the initial frequency for each case, then other fundamentals will be called harmonics or overtones. Now, we have this one, so the speed is equal to wavelength times the frequency, so the frequency will be equal to V over wavelength. Replacing it here, we shall have frequency which is equal to V divided by the wavelength, that is 2 times length. Because remember that here we were having length is equal to wavelength divided by 2, cross multiplication, then 2 times the length is equal to the wavelength. Very simple, and we are familiar with this. Now, if we have another case where we have, for example, this. Remember, for this case, we have 2 consecutive notes. This is a note, and this is a note here. This is a note, and this is a note here. Okay? So this one has wavelength divided by 2. This one wavelength divided by 2. Wavelength divided by 2. Wavelength divided by 2. When you are adding this 4, now we have 4 times wavelength divided by 2. Can I simplify by 2? Now the length of this string will be equal to wavelength divided by 2, not 2 times 2. Now L is equal to wavelength. Now let us calculate for this case. How can I find the frequency for this case? It is very simple. It is very simple that V is equal to wavelength times the frequency, and V, the frequency is equal to V over wavelength, and you have seen that wavelength is equal to 2 times length, So frequency will be equal to V divided by 2L. So now you may ask yourself, how many overtones were we having? Now if I have this 1, 2, 3, 4. 1, 2, 3, 4. So the length here, length will be equal to wavelength, that is 2 times wavelength. So that's a wavelength divided by 2, wavelength divided by 2, wavelength divided by 2, wavelength divided by 2. So here wavelength will be equal to length divided by 2 for this case. So if we have this case where wavelength is equal to L divided by 2, so the frequency will be equal to V over wavelength, that is L over 2, which is equal to 2V over L. And this L was equal to 2 times the wavelength, so that is 2 divided by L. Now 1, 2, 3, 4. So now we have 1, 2. So now we need to know the general formula for the vibrating string. But if I know 2 times V over L, remember, very interesting. Don't you see that in strings we have specific speed? Because in the string still, like you may ask yourself, what is the tension? So if I apply the force here, the string is attached. Now the force in this string will be the tension. So the speed is equal to square root of tension divided by mu. What is mu? That's mass per unit of length. So T, that's tension of a string. Mu, that is mass per unit length. Okay? Now, applying this V, so frequency will be equal to 2 times the square root of tension over mu, then divided by L. Okay? Now, for the fundamental, let us find how the fundamental frequency will be. Then you can find the general formula for the vibrating string. Remember here, we are in production of sound waves. Now we are reaching to the third case where you have sound which is produced through vibrating string. And most of us, we like guitar. That's a good example of vibrating string. So for the fundamental frequency, here you have wavelength divided by 2, that's the length. So 2 times the length, that is the wavelength. Okay? Now, if you have this case to mean that V is equal to wavelength times the frequency, so frequency is equal to V over wavelength, that frequency is equal to V over 2L. Okay? So that's the fundamental frequency for vibrating string. Remember, all frequencies other than fundamentals, they are called harmonic or overtones. So don't be confused. So now we have the fundamental frequency, let us write F notes. So now we are going to find an example where we have to apply this formula. But what is necessary is to know that this one has wavelength divided 5 by 4 by 4. Now the length will be wavelength divided by 2. That's the length. For this case, then you shall use these fundamental formulas. V is equal to wavelength times the frequency. Frequency is equal to V over wavelength. Then also V is equal to wavelength divided by period. To mean period is equal to wavelength divided by the speed. So these are basic fundamental formulas that we are using in sound waves. If you know these four formulas and you know each case how to find the length, it is very simple to know how to find the frequency at each harmonic. So thank you very much. We are going to help you to apply this formula. But don't you see that is very interesting? How we are linking the first case, the second case, the third case. Now we are going to use this formula to help you to understand very well how to use this formula. So if you need more, please subscribe on our YouTube channel. That is Ikaramu TV. That is on YouTube channel, but also on our website. All lessons of physics, specifically for senior 6 and the other lessons in the other classes, please find them on www.ubumenyi.net. Thank you very much. I love you. I love my students. I'm Charis. Thank you. Ciao, ciao.